Okay, so what we did in the last video then, quickly, we created a shader class. We we instantiated it. So shaders there, and then you've got create a shader where you pass in the constant character array of where the location is on the hard drive, and then you pass that into the create from files function in the shader, and then we use the shader. So we also added the shaders onto the project so that we can just quickly open them up and have a look. We haven't got anything written in there yet, and the shaders are actually stored in a folder. Oops, that's the properties, don't want that. Shaders are actually stored in the folder location, which is there, and then just shaders, and then the two shaders that we're going to use need the extensions on the end. So make sure you go to view and then file extension names. So inside the shader program, in the shader function, we have included the stdio so we can print to the console, the strings so we can actually use the strings that are returned from fstream, which is all about being able to use files and open and write and stuff to the files on the computer rather than just inside the code. So hopefully that makes sense. I didn't explain it very well, and then we just included glad for all the GL functions, and then we got the constructor, deconstructor, create from files, which is the function I went over before, use shader, a couple of uints for the shader ID and the uniform model. Shader ID is just the location on the GPU. The uniform model is basically a uniform variable is something you use in shaders so you can do some calculations inside the shaders rather than calculating and then passing it to the shader. Gives you a bit more control. So I'll be using that in the next video when we write the shaders. And then we just got a function for compiling the shaders and reading the files. So we'll just go through what the whole thing. So basically inside the shader, once you've created the shader, when you've called this function and passed in the shader locations, they pass them into read the files, and then they read the files and pass them into compile, and that's the end of that process. So we'll quickly go through that. Create from files. So we take in the vertex shader location and convert it to a string using read file. Then we convert the string into a constant character array just using this little function here, to C string, and then we compile, passing in the vertex code and the fragment code. So this is basically just taking what the read file returns and passing it into the compiler. So we'll go to read file, which is down here. You've got a couple of things here. So we've got std string for shader content, just initializing, well, that's actually uninitialized, but yeah, it speaks for itself. Shader content, that's going to be what's inside the shaders when we read them. The file stream, which is what we're going to be using to open up the file location and then read the data and pass it onto shader content. Okay, then file stream, open up the file with the file location. This part I'm not really entirely sure on. You've got the std, which I can't even remember what that actually stands for. Most people comment out std, but basically we've got std all the way around here. Standard, I don't think it's standard, ignore me. Input output stream, and then in. I guess you can change this to be out as well, so you're writing out files. That's my guess. I didn't look too much into the file stream header, which is this one here, and I did spend too much time on this bit in the video. So if the file stream can't open, then failed to open the file, that should probably say, and return nothing, because we don't want to try and do all this if we can't even open the file. Otherwise, then we've got a string called line, and while we're not at the end of the file, we get the line using this little function, and then we're basically adding to shader content, the string, the line that it's getting, and then we just put backslash n at the end of the line to add a return, so that anything we write in here, if I was to do this, then we get the return each time, and it doesn't just come out as one big string. I'll quickly show you. There you go. So it's including all the lines. If you were to just have it without the backslash, then you just get it all in one big chunk. No returns basically in the string that it's getting. So yeah, once we've done that, we close the file stream. At the moment, we're printing the shader content because we want to make sure that it's actually reading. We don't actually need that anymore now that we know that it's working. And then return shader content. Something I didn't look at was actually what it's saying, because it's probably saying something about not being able to build the data, but it isn't at the same time. Maybe it's because there's nothing in there. If I was to put something in there, what would it come up with? Because it should be trying to compile the shaders. Yeah, there we go. Failed to compile the vertex shader, failed to compile the vertex shader. Failed to link shaders. Why is it coming up with vertex shader twice? Did I? There we go. That should be fragment. Silly me. Yeah, so now we'll go through the compile part. So we've gone through the read part, which is returning the shader content. So the next stage, once it's read the file, converts it to C string, and then we pass it to compile function. So in the compile function, we have shader program equals gl create program. So we're creating a program shader program on the GPU, and the shader ID is the location. So we're getting the location by calling this function, because it returns a uint. And if we fail to create a shader program, then fail to create shader program. After that, then we create the vertex shader by creating a shader with this enum, I think it's called. Create shader, GL vertex shader. If we fail to create the vertex shader, then we do the same thing, fail to make sure we print that we failed to create the vertex shader. Otherwise, we can pass in the shader source, which will be passing in the code that we just got from the read file part, and then we compile it, and then we use these functions to check to see if the vertex shader is compiled and the status, and it returns a log to give us information on what's wrong with the shader. We get quite useful information from this, so it's pretty good. We do the exact same thing for the fragment shader code. We create the shader, compile it, get the IV to make sure it's all compiled and stuff, and then we ignore it for a bit. And then we attach both the vertex shader and the fragment shader to the shader program that we just created at the top of this function. Yeah? And then get the shader ID, make sure it's linked program there. Return the result. If the result's false, then fail to link shaders with a log. This uniform model bit is basically getting, when we write the shaders, it'll make more sense, but basically uniform model is going to be a variable called model on the shader, and we're going to be using that to translate and stuff, put any transforms on the model that we're drawing. I just thought I'd put one in there so we can see it. And then afterwards we delete the two shaders that we're no longer using. This actually just marks them for deletion because they're still being used in the shader ID, which is the shader program, but the actual shaders will be deleted once the shader program's gone. So that's why in the last bit with the deconstructor, if the shader program is not equal to 0, then that means we've created a shader program. We need to make sure it's deleted, so we just call delete program. I think that goes through the entire thing. In the next video, we're going to be writing shader code, which is going to be good fun. I hope that wasn't too lengthy. Nearly 9 minutes. That's not too bad.